For, well, decades now, we've had this one big idea about how our minds work. But what if that idea is just completely wrong? Today, we're diving into a really radical new theory. It suggests that your thoughts aren't just bits of information, but actual physical motion. Let's get into it.
You've heard it 1,000 times, right? Your brain is basically a super advanced biological computer crunching data like a silicon chip. And look, that's a powerful metaphor for sure, but it has some major limits. So there's this new framework, the Brain Kinematics Model, that basically says, hey, let's throw that old computer idea out the window and look at this in a totally different, much more dynamic way. So here you can really see the massive difference. On one side, you've got the old computer model. It's static, right? It's just circuits and ones and zeros. But then on the other side, you have this new idea, the brain as a physical machine. Here, it's all about energy, what the model calls strain. That's literally flowing and changing shape. And get this, memory isn't just data saved to a hard drive. It is the physical form that energy takes.
And this is the absolute core of it. Just try to picture this for a second. Every single thought, every memory, every emotion you have isn't just information. It's physical motion. It's a literal wave of energy moving through your brain. So we're moving away from thinking about hardware running software and more towards this incredibly complex, self-regulating system of flowing energy, almost like water.
Okay, so this brings us to a really important concept, neural strain. If you're going to remember one thing from this is it. It's the big, unifying idea for pretty much everything the mind does. A great way to think about it is like the brain's own internal weather system. You've got these currents and waves of energy constantly moving around, interacting, and that interaction is our mental experience.
Now here's where it gets even cooler. The model suggests that this neural strain acts like both a particle and a wave. So on one hand, when you have an unresolved thought or feeling, it doesn't just vanish. It leaves behind these little localized packets of energy, kind of like tiny particles. The model calls them residual strain packages. But then, and this is key, all those little particles come together to create a bigger field, a strain carrier wave that flows across your whole brain. And that right there, that's how one small nagging thought can end up affecting your entire mood.
All right, so if everything is motion, that leads to a huge question. What about memory? How does this new model explain one of the most basic things our brain does? What even is a memory in this new world?
Okay, check this out. It's actually a pretty brilliant way of looking at it. The model says different kinds of memory aren't like different folders on a computer. Nope. They're just different speeds of this energy flow. So your working memory, what you're thinking about this very second, that's a really fast-moving flow. Then you have short-term memory, which is a bit slower. And then all the way at the bottom, long-term memory is the slowest, most sluggish flow of all.
And I have to say, this analogy from the original paper is just perfect. It makes it so easy to grasp. Long-term memories aren't like frozen files in a cabinet. They're more like glass. Yeah, glass. It looks totally solid, right? But it's actually an incredibly slow-moving liquid, flowing at a rate you can't even see over decades. So your deepest memories, your very identity, they aren't static. They're slowly, constantly flowing and changing over time. How cool is that?
Okay, so we've got memory as motion. What's the next logical step? Well, what about consciousness itself? The Brain Kinematics Model, let's call it the BKM. It has a fascinating take on this, covering the whole spectrum, everything from deep sleep all the way to being laser-focused on something.
So it really boils down to two key things, amplitude and frequency. Your unconscious state, think deep sleep, is all about high amplitude waves, big, slow, powerful ocean swells. But your conscious state, that's the total opposite. The waves have a low amplitude but a really high frequency. They're like those quick, sharp, complex ripples you see on the surface of the water.
And this just builds on that idea perfectly. It shows us that consciousness isn't just an on-off switch. It's a spectrum, a continuum. You can see this clear progression, right? You start with the big, diffuse flow of the unconscious, then move into the subconscious, which is kind of semi-coherent, and finally, you get to the focused, high-frequency flow of your conscious mind. It's all the same energy, just configured in different ways.
Which, of course, brings us to one of the biggest mysteries of the mind, dreaming. I mean, why do we even do it? Well, the BKM has this really elegant and honestly beautiful answer. It's basically the brain's nightly reset button, its maintenance cycle.
So let's walk through what happens.
Imagine at the end of a long day, your brain is just littered with these little bits of leftover tension, those residual strains we talked about. When you start to dream, your brain becomes more flexible, more plastic, which lets these strains start moving around, and that's when the hippocampus comes in. It's like the brain's master storyteller. It sees all these scattered little points of tension, and it does something the model calls curve fitting. It basically connects the dots and weaves them into a coherent story, a dream. And by doing that, by putting them into a narrative, the emotional tension gets resolved, and your brain finds its balance again.
So the big takeaway is this. Dreams are not just random nonsense. It's a deeply functional process. Your brain is literally taking all that stored up tension from the day, that's potential energy, and converting it into kinetic energy, into motion, so it can be integrated and resolved. It's the brain rebalancing its own physics every single night. Just amazing.
Look, I know what you might be thinking. This all sounds fascinating, maybe even a little poetic, but is it actually science? And the answer from the model's creators is a resounding yes. This wasn't just designed to be a cool new metaphor. It was built from the ground up to be a testable, scientific hypothesis.
And that, for me, is what makes this whole thing so compelling. The people behind it didn't just come up with the idea and then walk away. No, they laid out a whole roadmap for how to actually test it, to prove it or disprove it, using technology we already have. It's meant to be put through its paces in a lab.
So how would we actually see these energy flows? Well, here are just a few of the ideas they proposed. We could track the speed and direction of brainwaves, kind of like how meteorologists track weather patterns. We could use something called fractal analysis to look for these repeating, self-similar patterns in brain activity. We could even map how the brain switches from one state to another, or measure exactly how our emotions change the power of our brainwaves. This isn't sci-fi stuff. These are real experiments that can be done right now.
And it all comes together under this one big unifying idea, the continuity axis. Okay, what does that mean? The basic concept is that everything your brain is doing, all the different regions, all the different rhythms, all at once, is constantly trying to find the single easiest path, the path of least resistance. Just think of water flowing downhill, always finding the most efficient way down. That's our brain's fundamental drive, to balance its energy and stay stable. This axis is basically the organizing principle for our entire mental life.
So that's where we land. This brain kinematics model completely reframes how we think about the mind. We go from a static computer to this living, breathing, flowing physical system. It gives us a whole new vocabulary to talk about memory and consciousness and dreams. But it also leaves us with some pretty deep questions, questions about our own experience. So I'll leave you with this. If every single thought you have is a physical movement, a tiny ripple in this incredible dynamic field, what does it even mean to be still?